So hopefully you've all had your coffee because we are going to go flying through this. First, hands up. Who here has some exposure to web development in general? Raise your hands. Awesome. Some kind of web frameworks, Backbone, Angular, or you guys just do pure native? Okay. Functional programming. Who here has done functional programming? That was a trick question. This is Lambda Days. And Clojure. Any Clojure people here? Okay, sweet. You guys can just go. I mean, you have nothing to learn here. So if none of these things interest you, you should go to the other talk because I'm sure it's awesome and it's about Erlang. So who is this guy? And it's so light, it actually is completely invisible. Awesome. So hopefully my slides won't look like that. We'll see how that works. So who is this bloke and why is he talking to you? So I've worked in a variety of industries that are very different from each other. And I've worked in a variety of technology stacks that are very different from each other, whether it's object-oriented, functional, very low-level assembly, and so forth. And over time, I've gained some, perspective. I've figured out some things. And one of these things I figured out is, first of all, I am not a front-end developer. As far as graphics and Photoshop is concerned, I run away as if it was a plague. And even though I produce a lot of JavaScript and a lot of CSS, I don't consider myself a front-end developer, and I would never hire myself as a front-end developer. On top of that, it turns out that I'm not a very strong back-end developer either. Now, I admit I've seen lots of scary things, and I have developed a sense of smell for good and bad code. So I have a pretty high squelch filter if you've ever read a pull request from me. But on the other hand, I know a lot of people who are a lot smarter than me, right? Like I've come to accept that. So the way I fight this battle that there are a lot of smarter people than me is my forte, it turns out, is figuring out what people's problems are and solving them through software. Like I have a good knack for drilling down to the root cause that someone is really fighting with and then proposing a software solution. But because there's all these smarter people than me working in a similar field, I have to cheat. I have to figure out a way to be better than them. And the way I do that is I figure out what is the best tool for a job. So basically, I use stuff that most people don't use because it's a way for me to keep ahead of the curve, keep ahead of people that are smarter than me. And that brings us to this talk today, because here I am talking to you about ClojureScript. Because Clojure by itself is a really fascinating language. It's really well designed. They chose some very pragmatic things. They made some very pragmatic, very cool choices, and it's really nice how well they embrace the JVM. But we can have a discussion, we probably will, over beers later, whether Clojure, Erlang, Scala, or Haskell, for example, is the best suited language for a specific problem to solve. And so that's Clojure. But the thing about ClojureScript is ClojureScript and React.js, they basically blow the competition out of the water. There is nothing quite like it for the front end. So it becomes a no-brainer to talk about and start working with this stuff. So let's talk about web applications. And I specifically say applications, not websites. We're talking about big, complex monstrosities, right? That we keep pushing more and more logic into the front end. So in the beginning, there was jQuery. And jQuery was awesome because finally we solved browser inconsistency problems. And we could finally just start building things without worrying about what specific browser it's going to be running on. And it was brilliant because it let us build bigger and bigger things. But that basically turned to jQuery soup, right? Because at some point, we were building these crazy things, and the technology wasn't keeping up with the things we were trying to build with it. So then we came up with MV Star, right? MVC, whatever. There's a bunch of them, and they all basically are the same thing. And this let us build bigger applications than we could with jQuery. But basically what happened is we repeated that cycle. We started building bigger things, and now we have MV Star soup. And I have seen some of these monstrosities, and they are insane, trying to maintain this code. I'm just checking the time here. So basically, I have a feeling we're sort of affected by Stockholm Syndrome. We are these frogs boiling very slowly in water, and the project keeps growing in complexity, but because it grows very slowly, we sort of just keep adding on to the project. At some point, we realized that we went in a very wrong direction, but it's too late to come back, right? And we keep doing this over and over again. I imagine if we were thrown into that big bucket project from the beginning, that boiling water, we would jump out. But because the projects tend to grow very slowly in complexity, we don't really notice it until it's too late. So let me introduce maybe a different way of thinking about web applications. And instead of models, views, and controllers, let's think about a rendering and events. Because when you come down to it, these are two primitive axioms that need to be in every single web application. You need to have some way of rendering things, because otherwise, what's the point? And it turns out that as far as browsers are concerned, events are the only way to figure out that things are changing. So we can just build up on these two axioms. Let me just check my time. So I want to see how fast we're going. All right, sweet. So our first superhero today. Our first superhero today is React.js. Who here has played with React.js? Who here has heard of React.js? OK, so for a quick summary, React.js is Facebook's open source library that's a rendering. That's basically a better rendering engine than what we currently have. And I want you to forget everything you know about React.js in the sense of forget about flukes and relay and GraphQL and all this other stuff that Facebook is pushing out. I want you to think about React.js as a very primitive black box that's just a better rendering engine than what you have currently. So similarly to how V8 is a better JavaScript, it's an optimized JavaScript engine for your browser, React.js is your new optimized rendering engine for your browser, right? And in order to have a sensible discussion here, we need to have the same we need to build up some mental models so we understand each other. So the first mental model is what the guys at React were thinking when they were building this thing. Because they took the idea from video games and how video games are made. And that video games are designed in such a way that you have hardware that renders, for example, at 60 frames per second. And that's your critical code section. You can never let that slow down because people will notice that graphics just, there's lag and all these other things. So that's your critical code, 60 frames per second. Whenever the hardware isn't doing exactly that, it has some CPU cycles for you to do stuff in the application. And that's the only time you have time to do things in the application. So we're going to start building web applications in exactly the same way. Our browser is rendering at 60 frames per second. Our application is in a different, let's call it a different thread. And the only way we can communicate with the browser is through React.js. We can never touch the DOM. We can never touch the DOM, and the DOM doesn't know anything about us. Everything is through React.js. It's a brick wall. A second mental model that I want you to sort of envision is that everything flows downstream. Or if there's some Americans around, there's a much more vulgar version of that. So you have a data model, and then you have some code. And your code transforms that data model into a virtual DOM. And the virtual DOM is just a different data representation of what you would like the final browser rendering to look like. Oh, yeah, sure. Better? Sweet. OK, so over here now, over here, yeah. So we have a data model that converts your code into a virtual representation of the DOM. And then React.js takes over. You do nothing more. And React.js figures out what you wanted to render, and it figures out what the browser is currently rendering, and it just basically merges the two concepts. So if you want a more specific, more concrete example, let's take some data. So it's a vector with a hash with a tweet and some string. And you have some code that transforms that data structure into a different data structure, which is what you would like your HTML to look like. And that's the final output of your application. The React.js takes over at this point and figures out what is currently in the browser, and it figures out how to make the second part look like the third part. And you have absolutely no input and say into this. And the reason for this is when you, for example, change your data. For example, you add a second tweet. And your code generates a brand new web page. Because of the fact that you don't know what your browser is rendering, you can't tell it, just add a second element to the list, right? As far as you're concerned, you're rendering a completely brand new page. And the beauty of React.js is they have a very good diffing algorithm that figures out what really has changed and figures out the optimal way of doing batch updating of your entire application to render it in the browser. And everything flows one way, right? So this is just a different way of looking at the exact same problem. I want you to just keep this in mind because we're going to come back to it later. So you have some data. The gray one is your virtual DOM, and then that's your real browser. ClojureScript, next hero of the day. All this talk about data representation. It turns out ClojureScript is brilliant at data and converting data from one thing to another. But if we want to talk about ClojureScript, we got to talk about Clojure. What is Clojure? Well, Clojure is a Lisp, yeah. But Clojure is a Lisp that gives you all of these crazy things. And what does this have to do with ClojureScript? Well, it turns out ClojureScript is exactly all of those exact same things, except the interop is with JavaScript instead of with the JVM. Now, I want this to sink in for a minute. For people who are right now developing applications with CoffeeScript and _JS or with TypeScript or Dart, look at all this functionality you get for free. This is not just pretty syntax sugar. These are completely new semantics that let you think about your applications in brand new ways. And you get all this for free, and this is not some crazy dream. This is something you can go home and build production apps right now. It's crazy that we're not all programming ClojureScript right now. It's just crazy. There must be a catch. What is the catch? I'm sure, you often hear about all these languages that give you all these cool things, but then when you sit down to actually do something with it, it turns out that it's a nightmare. I'm sure that's exactly what happens here. So in order to sort of disprove this notion, we're going to build a Hello World app. First, we need to address the elephant in the room. The elephant in the room is that this is Clojure, and so it has parentheses. And you need to deal with this. We're all adults here, and this is something you have to deal with. It's a Lisp. It has parentheses. If this is the thing that's blocking you from building much better and complex applications, then you're in the wrong talk. Seriously, I'm not even going to try to convince you otherwise. But let's say you're a little more adventurous, and you actually want to try this out. You need to have some understanding of how Clojure syntax works in order to understand the slides. So this is your 30-second introduction to Clojure. That's a comment. I'm shaking. That's a function evaluation. This is a way to define a function. We're defining here a profile, which is a hash with some keywords, strings, a vector, and a set. This is some syntax sugar for pulling data out of a hash and setting new data in a hash. And then that last example on the bottom, which is barely visible here, is a little example of how destructuring could work. Also nice syntax sugar. We've got a little time. So is there any questions about any particular syntax here? What is so funny? Okay, I'm just going to move on. Shout out any questions. You all know Clojure. I have no reason to be here. I can go home. Sweet. So you've got the syntax down. But any real programming environment has a little more than just syntax. So let's introduce boot. Any Ruby developers here? Hands up. Or have played with Ruby at least. Okay, so boot is like RBN plus reg plus gemfile plus bundler all rolled into one with a cherry on top. So for anyone who hasn't done Ruby, basically first of all, this handles your runtime environment. So it figures out exactly which version of Clojure and ClojureScript you want to run, and it runs it in a sandbox. It figures out all of the dependencies you listed and makes sure there's no conflicts and bundles all this together in order to run it. And then on top of this, it lets you build your own custom tasks. So it gives you a way, for example, for you to define what it means to build a development or production version of your application and deploy it. Right? So it does all of this, which is awesome. And there's a huge asterisk to boot because line is a de facto standard in the Clojure community. It does exactly all of those same things, but it has a very different internal implementation. Now, the reason why I'm going to talk about boot and not line is boot configuration fits on a slide. Line does not. And the second reason is that today, maybe not tomorrow, but today, if you're interested in ClojureScript, but you have not already drank the Kool-Aid of Clojure, you just want to get started, boot gives you a much better ramp of experience for just ClojureScript programming, right? If you just want to go from 0 to hero, boot is something I can explain in 2 minutes and you're good to go. Line, a little more difficult. But there's nothing wrong with line, so go ahead and use it if you want. The other technology that we need to have is a wrapper for React.js. So in this case, we're going to use rum. And again, huge asterisk. Ohm and Reagent are both very fine libraries, and they are far more mature. So I've used both of them. They're really good. And the reason we're going to talk about rum is, first of all, it has very interesting semantics I'm really excited about. And the second reason is, because of those semantics, it can emulate Ohm and reagent. So using just this one library, I can actually talk to you about all three. And you can decide which one you want to use later on. And rum is definitely very alpha right now. So, just saying. Oh, very good question. So why do you want to wrap React.js? First of all, because React.js, the API is very object-oriented. So it creates very non-idiomatic code in Clojure. I mean, there's no reason why you can't do it. All those libraries do is basically write a couple macros that wrap the React.js library, right? So it's something you would have done probably in your code anyway, because it doesn't look very pretty if you just keep using the object-oriented version in your code everywhere. So all these libraries at some point, people were using the APIs specifically and just started writing their own helper functions. And so basically this is what turns out. But the nice thing about it is, as we'll see, after you wrap just the nice, better syntax, you can add additional semantics that you would have a hard time doing if you just use standard React. But at the end of the day, this is just pure React code, right? It's just nice wrappers for it. So you need 4 files to write a production ClojureScript application. So anyone who has ever done, ran Rails new or built any kind of backbone project or anything, you don't believe me. But all you need is a HTML file, a CSS file, and that's totally optional, by the way, an actual ClojureScript file, and the boot.build, right, that I mentioned. That's going to help you set all of this up. The HTML file is just, right now it's a classic HTML5 skeleton, the most basic thing you can do. Notice that there's no mention of ClojureScript or different runtime environments or anything. The only thing you really have is this div ID app where we're going to mount the application into. Boot figures out at runtime and injects the proper script to make everything work, whether it's a development or a production environment. This is basically a whole world of ClojureScript. We have a namespace, hello core. We require the rum library. We create some data. So we have a post with a title and an author. And we create a React.js component. So rum devc is a macro that takes what looks like a Clojure function and wraps it in a React.js. It creates a React.js component class and creates a constructor for it and implements that as the logic of that class. So if you export this out, this actually looks like a React.js component class that you can use outside of ClojureScript per se. In this case, this function just deconstructs 2 pieces of data from our post and creates a block quote text. And the last thing that happens is we mount this. So rum mount, that's the component I'm interested in, and that's the part of the DOM where it should be mounted into and should be rendered. Build.boot. So what we have here is we basically set a source in HTML, so that's where all files are located. We include the dependencies we're interested in. In this case, we're just interested in ClojureScript, React, and rum. And we include a bunch of helper development plugins, basically. So with this, we're going to get some CLJS.js, which is a way to pull, which is a neat way to pull in additional JavaScript libraries like Memento or whatever else you need. You have CLJS REPL, so you're going to get a browser of the REPL, REPL browser. You have boot reload, which is going to reload your code anytime anything changes, and boot HTTP, which is going to serve your files. So you don't actually need to have a server running, HTTP server. So those are the helper functions we get. And the way boot works is these are defined as tasks. And tasks are something that, on the one hand, you can use in your code as a function. And on the other hand, you can run it from the command line as an option. So if you don't want to keep running the same commands in the command line, you can basically compose using functions, right? Because this is functional programming. So you basically compose a bunch of tasks. I call this build dev. And then I use build dev as a part of my dev thing. So when I run boot dev in the command line, it basically starts watching all my files for changes. It serves all the files. It creates a REPL for my browser. It builds the entire project. And it will auto-reload via WebSockets whenever anything changes. So what just happened? In 5 minutes, we basically got a setup that's probably better than what you're currently doing in your front end. Because on top of everything else that's cool about it, you have auto-reloading via WebSockets, right? So, and you have an actual browser REPL. This is not Node.js. This is a REPL into your browser in your Chrome. So when I, for example, add 1 to the string 2, ClojureScript tells me that's not a good idea, but it's JavaScript, so it'll return a result. And if I tell it, alert hello, an alert pops up in my browser because this is connected via WebSockets to my actual browser running session, right? So this is amazing for development, just for quick prototyping. So we've got a hello world, and it's great, but let's talk about building big applications, right? Because that's why we're here. So rendering, I guess you can explain it as you have a data model, and then you have a data transformation, and then there is no step 3 because React.js takes over. But in fact, and the thing about React.js is if the data transformation that comes out of it is the same as what's in the browser, then React.js is a no-op. It's not going to do anything. But it turns out you can do even better than that, because if you know that nothing has changed, you can actually tell it not to even run the data transformation because there's no point, because you know nothing has changed. So the thing about RUM mixins is you can specify logic of what it means for things to change. And each project is different, and that's why RUM doesn't tell you what you should how you should define changing state. It says, here's this mixin API, do what you want with it. So an example of a very basic mixin is RUM static. We meet our next superhero in Clojure, which is immutable data structures, or persistent, if you will. And if you have persistent data structures, you can abuse it in the following fashion. You can say that you're creating a label that's a static, and static basically says that this thing never changes unless the arguments change. So when you do label hello and you do label hello again, there is no actual rendering because the text has not changed, right? It's the same string as far as persistent data structures are concerned. And this is actually even faster than if you do React.js native, because ClojureScript gives you that guarantee that this is an immutable data structure. It turns into an O of 1 operation. It's checking pointers, right? This is better than what you could get out of standard JavaScript in React.js. So RUM reactive, that's another kind of mixin we can talk about. And by the way, this is exactly what reagent does. So if you want to use reagent, this is what you're thinking of. So reagent, basically, it leverages ClojureScript atoms. So what are atoms? Clojure has a couple of nice semantics, a couple of different tools for talking about concurrency and sharing state. And one of the things is atoms. And atoms are a way of talking, basically sharing immutable, figuring out a way to share state between different components that's independent of each other. And it gives you some nice guarantees. For example, you can do atomic updates that are free of race conditions. And on top of that, you get some nice APIs that you can actually, for example, watch for changes on an atom and trigger, which will trigger some events. So an example of how you would do this, you use this in the front end is, for example, you create an atom called to-do, which has a title hello. And you create this component item, and basically you say that this component is dependent on changes to this state. And whenever this state changes, I want you to re-render magically. And then you mount this as a to-do, and then every time somewhere in the code someone modifies this atom, this component knows to re-render itself, right? You've decoupled that information. Another cool trick you can use with atoms is sometimes there are components that are separate, but they need to share some state. And it's sort of, it's local state to them, but it's not within a specific component. And so atoms are a nice trick for solving this problem. For example, if you have a text field and you have a search button, those two components share a piece of information, which is what the user typed in. And a nice way of doing this is wrapping this in a Clojure, and the Clojure shares an atom called val. And the input box reacts on this val and resets the val, and the button can read that val at the moment the user clicks on it. Is that clear? Awesome. You guys are the best. No questions. RUM cursored. So this is what Ohm does. Ohm has a very different philosophy. Ohm has a tendency to say the way to build big applications is to have one big atom. That's your just entire world state. And all of your components figure out what data they need from that atom. This has some very nice properties when you build a system this way. One of these properties is that you can start thinking about changes as not passing an atom around, this huge big state, but you can think of it as a stream of diffs, a stream of small updates. Another nice thing about this is that you can actually dump your entire state, right? You can serialize it. You can serialize it to local storage. You can send it over the wire. And then you can, for example, load it up in a new browser, and you see the exact same thing that user was looking at, because the entire application is rendered from that one big state. Another nice thing that you get for free is you get basically infinite undo. Because undo basically at this point means that when something changes, you don't lose that old version of the state, you store it somewhere, right? And because, yes, question. We're talking at the browser level, right? So we're talking per session, yeah. But that's not a problem per se, because if you got to do multiple users, there are ways around that, right? Yeah. But yeah, true. I'm constantly thinking of the browser, right? This is where I'm at right now. Single thread, one user. So undos are basically for free, and the best part is because of immutable data structures, they're actually very cheap. You don't waste a lot of memory to store all these additional diffs. So that's what Ohm does. But there's one problem with this approach, and the problem is that basically all the components get this reference to this huge piece of state, and they need to know which information in that state is relevant to what they need to render. So this creates a very crazy coupling between what the global state looks like and what each component needs to know about it. And cursors is a solution to that problem. And the way cursors work, all the way on the bottom here, is basically you say, this color thing that label is interested is inside app settings color. And it creates a cursor reference to that part in the state. So when someone changes color, label gets updated even though it doesn't know anything about the fact that its information is in app settings. Clear? Less nodding than last time. Okay. So those are some of the built-in mixins you get with the library. But the thing is, because of the semantics, you can basically build your own. And on top of that, really nice thing is you can mix and match. So within one application, you're going to start using different versions of this render on change mechanism for different parts of the code base. Because, for example, your main app maybe is reactive, but then some parts are cursored, and then some parts are static, and then some parts are completely different, right? You can write your own stuff. What does that mean, write your own stuff? Well, a simple example is something I call rum delayed. Here's the problem you have to solve. You have a post, like a tweet or a blog post or whatever, and it has that string, posted X seconds ago, X hours ago. Now imagine your use case is you want that to always be true. So as the user leaves the web page open, you want to see that thing ticking correctly and updating itself. Well, since you have a granularity of 1 second, the most obvious solution is just to every second check if I need to re-render this. But that's silly, because once you have it in days, you have a granularity of days. You just need to know that next day, check if I need to re-render this. So this is something that creates a local state and a very specific mechanism for rendering, but it's very specific to the view. There's no reason why the rest of the application needs to know that something like this exists. So this is a perfect example of where you would create a custom mixin for this, right, to explain this situation. Another much crazier thing is DataScript. Who here has heard of Datalog? So this is Datalog. One of the things about let's say popular applications Datalog right now is it's the query language for the Datomic database. So it's a query language. It's similar to SQL, right, to some extent. And it has very specific properties about how it works. I don't want to really get into it. But the thing is, you can basically start writing your views as queries on some data. So DataScript is a port of the Datalog query language to JavaScript. So you can actually have an in-memory database in your browser, and you can query information against it. And on top of that, you can create views that are not dependent on state, like an atom. They're dependent on when this query would return different information, that's when I want you to re-render itself. And the beautiful thing is data log is reversible. So let's say you load up a bunch of data, and then over WebSockets, you start getting more data, right? And then at the moment that a WebSocket comes in with more data, you can actually reverse all of the queries that are on your views, and you can figure out which views potentially are affected by this change without actually running any of the queries. It's brilliant. But it's crazy. Why would you do that, right? Well, here's a use case. Here's a common use case. This is GitHub issues with Rails code. But this is a very common scenario in our, let's call it business applications these days. And the issue is that you have a list of things, and you have a ton of filters, right? And your requirements are basically anytime anything here changes, you need to change this. And on top of that, the requirements usually become crazy. Like for example, if you select a specific milestone, on that author dropdown, I only want you to show authors that are actually legitimately in that milestone. So you have tons of different states that are affecting each other. And the way this is usually, the way this is usually implemented, this is what GitHub does, is every time you do something here, it sends a query to the backend that has all of these different parameters as query params. And the backend basically has all this logic of what the front end should do for specific situations, and then it returns a JSON back of what things you should display. But that's silly. It's silly because Rails issues, which is a pretty big project, has what, 6,000 issues. Let's say there's 10,000. Let's say there's 100,000 issues on a huge GitHub project. If you take all of that data just as raw text of, like the titles and all the different labels you can sort by, we're talking about a couple 100K of data, maybe a megabyte. You could just load this up once into your browser and basically render all of these things using a query, which is insane, which is much faster than anything you could do just counting the round trip time to the server and back. I'm not even talking about the fact that you no longer have to implement front-end logic on your back end. You wouldn't have to have some crazy endpoint just to do this thing, right? Because this is basically just view logic, nothing more. And if you think this is just crazy dreaming, the guy behind DataScript wrote a hackathon project called Acha Acha. And basically this is like one of those, you get badges for different kinds of commits and things. So this is this project that the first time you load it up, it's about a meg of data, I think, right now, where they just keep adding more and more repos to it. It loads up all of the repos, all of the users, and everything. And whether you're looking at the page of all repos, or you're looking at a specific repo page, or in this case, you're looking at a specific profile page, all of this stuff is rendered in real time. All of this is done by querying, right? We just load the raw data into the browser, and then we render all these views using query language. Events. So we've covered one half of the equation, and that one half of the equation is rendering. Now let's talk about events. Because as brilliant as everything I've been talking about is, we've basically solved the problem of, we have a data, which is some domain data, right? It's domain data, which we figure out how it should be rendered. For example, one domain data can be rendered into 10 different things, and then we render it into the browser. But the problem with front-end development is it's all about events. It's all about changes that are happening. Nothing is static. Everything is dynamic. So the question is, how do we handle all of these changes? How do we handle these events from Ajax, from WebSockets, from user inputs, from JavaScript events, from thousands of things you can think of right now, right, that are generating events? What is this black box that's going to help me tame this beast and return a simple data model that I can use? Well, it turns out Cory Async is the answer that Clojure gives you for this problem. So what is Cory Async? First of all, how many people have played with Cory Async or have heard of it? Awesome. You people are in for a treat. So one thing that Cory Async is, it's a way of writing asynchronous code that looks and feels synchronous. Here's an example. Let's say I write an infinite loop that returns a value 1 every 250 milliseconds. And then on top of that, I write 2 more infinite loops. So I've got 3 infinite loops running already. And then I write a 4th infinite loop that basically takes this data that I was generating and renders it in some fashion. How does this work in JavaScript? Need I remind you that JavaScript has no threads? Silence. Sorry? There is no event loop. In JavaScript there is. The way this works is Go is a macro. And the macro parses your code, figures out what is asynchronous, and turns your synchronous looking code into a set of callbacks. In the case of JavaScript, because JavaScript doesn't have threads. In the case of Clojure, it'll either do threads or it'll do either threads, or it'll do parking threads, or it'll do callbacks, right? Like green threads and so forth. It depends on what you want. But in JavaScript, you don't have threads, so basically by default, it'll do callbacks. So basically, you're still writing the same callback logic you would do anyway in JavaScript, because JavaScript is all about asynchronous coding. But the thing is, you hide all of that complexity of handling and basically babysitting all of these callbacks. You can write code that looks synchronous, but that behaves asynchronously. I want to let this set in for a minute, because I want you to think about how you would write this in JavaScript without this kind of syntax. You would use promises, yes. There's some things that promises can't do that core async can, but I think we can get into that later. But even with promises, it wouldn't look this good.
We can use something like breakons.
Which is sort of like promises, right? Yeah. So what else is core async? Well, when you have a hammer, everything looks like a nail. Once you learn core async, everything looks like a queue. Everything looks like a queue. Seriously, I can't stop thinking about queues. Let's say you have a requirement, and your requirement is that the user has some input search, and I want you to search the web image and a video API for this query and return the result. But I'm only interested in the first result you get back. On top of that, we want this to be fast. So the first time you do this query and you get back a result, store it in local storage. And the next time a user searches for this thing, fetch it from local storage if available. And on top of all of this, I want this to be fast. If you can't deal with this in 1 second, I just want you to give up. I'm going to go to plan B. Now think about how that code, how those requirements would look in JavaScript, where you would have to handle all of those callbacks, and the callbacks are dependent on each other, because it's not enough for an API to succeed. It needs to succeed before any of the other ones succeed. This is how this code looks like in ClojureScript, right? This is not pseudocode. This is what you would write. You would write a bunch of queries, and they would all write to the same channel. The idea is that web query, when it gets back a result, it pushes it onto this channel C. And all these other ones do the same. And then we have a second channel, Timeout, and the way Timeout works is it creates an implicit channel that after 1 second will return a result onto that channel. And then there's this magic method called alt. And alt basically says, give me the first result from any of these channels and ignore anything else. It does exactly what you want. It does what it says on the box, basically, right? So this is the kind of stuff you can start building. Like these are the primitives. These are your new language primitives. So imagine what kind of new complex things requirements you can start thinking about when these are your primitives, right? So it turns out that core async, because of these things, is really good at decoupling code, because once you have channels, you start thinking about component modules as components, and the components, the way they communicate with each other is via channels. So anytime I have something that wants to do something, I give it a channel. I say, when you're done with it, just push it onto this channel, and I'll make sure that the right people start reading from this channel when they're interested in this. So basically, that core async solves that problem that we were talking about, right? Now for something completely different. We're 40 minutes, so we're pretty much right in time. I knew I wasn't going to be able to cover lots of stuff, and I don't want to keep you from lunch. So I just made this one slide that says, this is all the stuff that you need to learn because it's awesome, but that I don't have exact slides for. I mean, if you want to waste a little bit of lunch, I can probably go into a couple of these if you really wanted to. So transducers are super awesome. They're a really nice way of thinking about. It's like enumerable squared. It's a new way. It's like what enumerable should have been from the beginning. And core logic is basically prologue. Core match is pattern matching. React Native is what's going to hopefully come out soon, and it's going to be awesome, right? Because then I'm going to be able to do this on the mobile as well. I'm going to be able to apply all of these crazy things I just told you about. Sente is a really cool library if you are if you want to write a Clojure backend and a ClojureScript frontend. Sente does a lot of the boilerplate for you. So it has a way of figuring out Ajax and WebSockets and all of this other stuff. So it does everything for you. If you're basically committed and you don't mind that coupling between the two. Transit is the library you need to be using if you're doing ClojureScript and you're parsing JSON or anything else. It's just a really good library, and it's much faster than parse.json, the default one that comes with ClojureScript, because it uses native code from your browser. And Leaven is an implementation of Stuart Sierra's components, but it's one that works with Clojure and with ClojureScript. And basically, Leaven or Stuart Sierra components are a way of talking about even bigger systems. It's a way of compartmentalizing systems, much bigger applications into these systems that are independent of each other, and a way of figuring out, for example, which order things need to start in, what is the coupling between them, and so forth. If you're like me and you really like Haskell, for example, and you want types, Prismatic Schema and Clojure Typed are two very different implementations, ideas of what it means to create more type-safe Clojure code, right? So that's something you guys should really look into. And two real huge notions from Rich Hickey. Simple versus easy is a really great talk. You need to see it. And thinking about accidental versus essential complexity is also something that I want you to have on your radar. That's pretty much it. On a more personal note, I've been playing with this idea of basically bringing ClojureScript to more people. Like, this talk is one way of doing it. I did a Lambda Lounge talk, which is very, very different. It was live coding, and I'm doing a talk in Wrocław soon, which I think is going to be very, very different from this one, because why repeat the same thing, right? But except for that, I've been playing with this idea of building something of a bigger course, I guess, like a lot bigger thing that sort of takes you zero to hero and talks about what it means to build big things in ClojureScript. So if you have some thoughts about things I've said or things that you'd like to see, or if you just like to find out when things are happening, either find me at the conference, ping me later, or just follow me on Twitter or something. That's all I've got. Are there any questions? Yes.
Do you have any sample project, for example, GitHub, where all those technologies, all those libraries work together?
Yes, unfortunately I do not, and this is sort of what I was talking about with this thing I'm sort of putting together, but it's not live anywhere yet. Yeah.
The slide with channels.
Yes.
So what's happening if the timeout is if all the other queries are still on?
What happens with timeout when all these other queries are still running?
Timeout before all the queries ended.
Mm-hmm.
One didn't stop yet.
One more time, louder.
The queries which didn't stop yet before the timeout, they will still run, or they will be canceled.
They will be canceled, and actually all these queries are running because all of this code gets run at the same time, pretty much, right? Because remember, the Go block basically says, do this thing asynchronously, but keep writing code, right? So this code will basically spin up all of these processes and then exit, because there's nothing that says wait. Well, in this case, alt says wait, but if the alt wasn't there, this would automatically exit, and all of those processes would just spin off and they would die at some point.
Yeah, but if the timeout happens and there is more problem, so the main thread still is there, will the queries cancel themselves automatically, or will they still run somewhere on the backend?
They usually will run, because basically the HTTP query was already made. But basically the response from that at that point, when it comes back, the guy basically the code will say, I don't care about you anymore. Yes.
One comment about the GitHub issues. I don't think it would fetch everything all the time anyway. It would just paginate and get only like first 100 results. So, and the other thing is that if you get everything in the browser and just
Right. So to answer your question about the GitHub thing, where is that? First of all, if you do it the way you're saying that you page, yes, of course it paginates, but that's because it doesn't need to show all the results. But the round trip time to the server and back is going to be slower than if you do it in the browser, if you have all the data. And the other, you had a second part to your question, I lost it.
Stale data, yes.
Oh, stale. So the way this is implemented, and for example, this is what Acha does, is the first time it loads a page, it'll load up all the data it knows about, and then it keeps a WebSocket connection open. And whenever data comes in, it'll get that over WebSockets, right? And then it enters that entire process of hitting Cory Sync. Cory Sync figures out what data has changed, and then React.js automatically renders your page without you even knowing about it. It's magic. I know, it's awesome. Yes.
So I wanted to ask you about, in your talk you mentioned good parts about ClojureScript and Clojure in general. You haven't really talked about bad parts. And I wanted to ask you about that, and I want to ask you about state specifically. So as you mentioned, React.js is only for rendering, but what's your take on managing state? In particular, you know that Facebook, along with React, you have something like Flux, or in modern implementation, it's going to be Relay or something like that. So when you compose different things in React, like components, there is this problem of children-parent communication. And how do you solve that? How do you manage this kind of problem? Do you use like global state as an own, or do you?
Right. So the question is basically how does this compare to Facebook's approach? So the thing about Flux and Relay and so forth is those things are sort of there because they have this problem that they don't have immutable data structures and things don't flow one way. You can simplify a lot of the problems just by making sure that things always flow one way. So your question about how do components communicate, they don't. It always has to go from the top. So if a component wants something to happen somewhere else, it, for example, triggers some kind of event that gets fed into the core async and then it trickles down, right? So you can always, if you always think about it going down, a lot of the problems get solved. Now, as far as Relay and, for example, Flux, it turns out wasn't as great of an idea as they thought it was, and that's why they're introducing GraphQL. And GraphQL is actually a different sort of idea on this concept of data script, of data log. It's the idea that at some point we've realized that the way we did this doesn't scale. So we want to go back to the idea that we're going to have one big storage mechanism, and each view is going to write queries on this on this database. And it just so happens that that database is also synced back into the server. And there's absolutely nothing that stops us from doing this on ClojureScript. This is actually how I usually design this stuff. So I will have like something like that one data source. The views are dependent on the data source, whether through atoms or through like querying language or whatever. And then when things get updated, for example, you create a new post or something. You can, for example, then filter that back to automatically render itself. So in order to render itself, you need to say, add this post to the list of posts, and then it'll render itself. And then, except for that, a second event will fire that says, this post got added. I need you to make a communication in the backend, validate it, make sure it's okay, right? That's a separate thing. It's a separate channel, a separate communication. If the backend then comes back and says, no, you couldn't create this, you don't have permissions for it, it's not a side effect. Basically, you just create a new thing that says, this thing that I added is no longer valid, remove it. And then because you remove from the data source, it also trickles down and it gets removed from the view.
Would you advocate like creating only stateless components in that case, like and trying to propagate the changes
Yes.
only through stateless components?
Yes, but like for example, sometimes you have a state in a component that's not relevant to the application. So that's okay, right? Like things that are specific to the component, like local state for it. But anything else, it needs to go through the data model. And since it always trickles down, it's really easy to figure out how things are working. By the way, I didn't mention this explicitly, but it should be really obvious how easy it is to test systems that are designed this way. Because you can basically test how Cory Sync is going to update a data model as a unit test completely separate from rendering. And you can test rendering completely separate from how events modify data. Right? Yes?
Yeah, question from non-Clojure guy here. So maybe what is the, I mean, there is no one tool for everything, right? For all the jobs, no silo code. What are the projects that you would not implement using
Using those tools. I don't work on projects where I wouldn't want to do it as far as front end is concerned. In the sense that I like building very complex front end applications, and it works perfectly for that. Another thing I didn't mention is, first of all, Facebook's React is pretty, I don't know how we're doing with time. Do we have to go? Yeah. Let's just talk over beers later.
Okay, so